In this video, I'm going to talk about inflection points. Inflection points are points on the curve in which the sign of the curvature will change, meaning they could be concave up or concave down, but I'll talk about that as the video goes on. Critical points and inflection points are obtained in a similar manner. The first step to obtain them is to obtain the derivative of the function. So we have our function fx and we want the f prime x, but unlike in critical points, in this case you have to find the second derivative, so you have to do another derivative, so it would be f2 prime x, and now you make it equal to 0 and solve for x. So it's only one more step further. And that's how you find the inflection points. After that, you can just find the y value by plugging this x value into the first function. As I mentioned before, this could be concave up or concave down. And this is how it goes. So when f2 prime x is positive, the function is going to be concave up. And when it's negative or less than 0, it's going to be concave down. So this is the concave down section. This is the concave up section. A good way to remember this is to separate the graph into two portions, and you're going to give the name to what you're doing at the end. So you're going down at the end of the graph, so that's going to be concave down. And in this case, you're going up at the end of the graph, so that's going to be concave up. You will use this to graph a function when you're analyzing it. Now I'll solve a quick problem. So our function is 2x cubed minus 4x squared plus 5. The first step is to find the first derivative, so f prime x. That's going to be 6x squared minus 8x plus 0. So you can just leave it like that. Then you want to find f2 prime x, so the second derivative. That's going to be 12x minus 8. And you make it equal to 0 and solve for x. So 0 is going to be 12x minus 8, and then x is going to be 8 over 12, which is the same as 2/3. So that's our first inflection point. Then you want to solve for y, in this case, plugging it into the principal function. So it's going to be, you can just write this as y. Y is equal to 2 to 2/3 cube minus 4 2/3 squared plus 5. Then this will be 2 times 8 over 27 minus 4 times 4 over 9 plus 5. So we get 16 over 27 minus 16 over 9 plus 5, and that is 103 over 27, or 3.81. So you could write your inflection point as 2/3 and 103 over 27. Sorry, let me fix that. And about the concavity, x is 2/3, so x is above 0, which means it is concave up. One more thing before I end the video that I forgot to mention is when you get that your x is equal to 0, that this means that f2 prime x does not exist. So that's our second part of the function analysis, inflection points. If you found the video helpful, like and share with your friends.